So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 128, and in this video we will continue with arrays, but specially talk about this array to pointer decay. And in our last video we had this, we created here an array that was in our last video. That was our int database with 2 array elements, and then we showed this here that the first element is indeed 0, and then we created also here on top a function which can take an array. So this is the first time we make an array as a parameter, and we defined the type of the array exactly the same type of this array, which is 2. So I can 2 int, so I can take this 2 int here, and we pass this in, and then we saw something strange, that this passed value here, which we expected to be a copy, is not a copy, because we changed here the value from this passed argument, and it changed also the caller's argument. And now it becomes even more strange. Why? Let's see what happens with this array to pointer decay. So we can read this fast so that we get a brief understanding. It says here, behind the scene it will happen an implicit conversion. So which means an array is behind the scene converted to a pointer, and it says here to a value pointer type. So it is converted to a pointer type behind the scene. And then it says here it constructs a pointer. So this conversion constructs a pointer to the first element of an array. Okay, that explains a little bit why this array here is not really a copy, which we expected, because behind the scene this one will be converted to a pointer. And we know about pointers, they are connected to the caller, because the pointer points to the caller. In this case, we learned this, a pointer points all time to anything, and when you call here, for example, this database, this pointer here, which is created behind the scene, will point to this one here. And that's why when we change here this, when we use this array name here and change it here, it will change our value. That makes sense a little bit. But the problem is, okay, all good and fine. The easy solution is just treat this array here as a pointer. That's so the easy solution. But what does this mean, treat this as a pointer? Which means if you want, for example, that this array should not change here anything, you can write again here const, then it will work. So you see, it's not, you can't write here anything. We know this is const qualified. Same like references, right? Normally we do this with references, but with const we can do the same thing. And references behave like a pointer too, right? They say references, we talked about this, behaves like a pointer too. They have only some settings which are not the same, but in general behavior, yes, like a pointer. So, but now I show you one more thing. Let's say this one behaves like a pointer, which means we can replace this parameter with a pointer too. What I mean with that is we can create here a new function. Let's create here a function, a second function here on top. Okay, and let's say because this behaves a pointer, I can perhaps use a pointer here. So I write here a pointer, and then I write here, for example, array. No, let's say pointer. No, pointer used as array. No, that's a very bad name. Array can used as pointer and param. Param means only parameter. And this is the description. We can array can use as pointer, means exactly what I do here. You see, I create a pointer here. This is a pointer now. This is pointer declaration, right? With asterisk in this int. And which means I can pass now here an array and it will be used. And the reason for that is not because it is because I say it, because exactly of this text here. Array to pointer decay. It decays behind the scene to a pointer and it makes it available. And let's continue with first with this example, which means, okay, I have now created a function. Let's call this one here too. Of course, we could also use the overload here, which means you can call this one. One is with pointer and one is with array definition, but let's call this here 2 to make it absolutely clear that this is another function with a pointer param. And yeah, the question is now what I do, how I call this. Let's call this one, actually we call it just normal, and that's also interesting. I go here down, here's the function, and here, interesting, I can just use this array name, database user ID, and the reason for that is this one will be like I said, array to pointer decay. We will discuss this a little bit more in detail, because implicitly behind the scene this array here becomes a pointer, and this pointer says yes, I can use you. That's so the simplified explanation, which is not accurate, but to understand as a programmer, we don't care so much. We want just understand it so that we can use it, right? Very fast. And in detail, we will go later. So, but let's finish this one here. All right, we have created now a call. We used an array, which is this one here. But this time, we passed it to a pointer. And the reason why we can do this is this array here is converted behind the scene. And yeah, if something happens like that, we can't see this. We have to know it. We have to learn it. That's the bad thing about this one, because this implicit conversion, what happens behind the scene. Sorry. And that's why we have to talk about this kind of stuff in theory, and I have to explain this one to understand this. But in practical use, if you know that this one is treated like a pointer, and then you can pass an array as a pointer, that's enough. That's the practical use. Very fast, very straightforward, not too complicated. The only difference is now you have to know how to use this one. What I mean with that is you passed here an array, right? So here, this line is saying, okay, I call you with an array. And now, okay, behind the scene, this array is converted to a pointer, because this implicit conversion behind the scene, that's cool and fine. But how we are using now this one? For example, I want to access the second element here of this array, and I want to change it here. How I do this with a pointer. And normally, what we do with a pointer normally when we change a value, let's say not an array. Normally you would write something like that. Asterisk, a difference operator called here, very important. And then you would say, okay, I take the variable name normally. I put this one in. And then I have normally access now to the pointed value with this one, and I can set it what I want. That's the normal way to do this. But we can test it what happens here. And if I do this, and let's put this one here one more out. Let's say here I copy this line. I want to print it out. And all right, I think that's cool. And let's make here an end line too, because I need this. Ah, it has it. Okay, nice. I start here and let's see what happens. And indeed, it worked, right? It worked. That's what we do with pointers normally. here we have first printed out the first value here. That was this one, and it was 4. Nice. Then we have called the first function, which is this one. And we know when we set this one here, this is an array call. We set the array first element. Here we specified it exactly which element we want set. To 33. Yes, it worked. It's 33. Nice. And here we called the pointer. And that's what we do all time. And it's set to the 432 like I said it here. But there is one problem when we watch this a little bit careful. Here is a difference, right, between that. And the difference is only that here I can specify the slot, and here we have not learned how to specify the slot. For example, this one is slot 0. But what is if I want to change the second slot? So I want to change not here the first slot like here, which is this one. I want to change the second slot. And now there is another term called pointer arithmetic. We will talk about this one too, but which pointer arithmetic in short, we will not talk in this video about. This means just you use addition, subtraction and all this kind of stuff, but not like in math. It means you use it, you replace it just with the address, which means you replace it just, for example, in this case with the int, it points to the first address. If you say +1, it will point to the next int address. And that's a little bit a topic for the pointer arithmetic. But in our case means, in the short and simple solution means, we need just to tell this pointer, because pointers work with addresses. And this one we can specify to point to the next address here, which means go to the next address, point to the next address, and the next address in this array is then the second value for. All right, and then I show you how you make this one, because it's same like here. Let's start from start here. So I want what? What I want? I want access the second address. I start again with my differencing operator, because the differencing operator means I'm interested in the value of the pointed object, and that means I'm interested in the value of this array here. So, and now I have to say I want to go to the second address, not the first. The second address is actually, again here, I take this one here. This is the parameter. I place it in, and I use here parentheses. And then I make here +1. And this what I do here is not mathematic. This is pointer arithmetic, which means this one will just jump to the next address, which is in line. And we are using here an array as an input, which means we know exactly that the next one will be, if all is right, this address of the second value. And then if I assign now the value here, for example, of 666, I point it out, and now I print this, and what we see here 33. Why we see here 33? Because I just printed out here the 0 element. I want to see the second element, which means here the second element here, I print this one out, and now we see indeed that what we changed, the second element is indeed 666. And here this one is a special case for pointer arithmetic. You can read this again a little bit in theory, and we will talk about this again, but not in this video especially, because we need first understand a little bit more this array pointer decay. But so far what I showed you is the short version. If you understand this kind of stuff, that's enough for the practical part normally, because you have just to know that an array can pass to a function with array can pass to a function in array form, which is this one here. Here it is clear you are passing in an array, and it can be passed here also as a pointer form. Here's not clear that you can pass here an array, because normally when you read something like that, you expect a pointer. And that's a little bit confusing again, but you have to know an array can be treated as a pointer too, and then you can do this kind of stuff, which is just assigning a value with the next, for example, accessing the next value. Let me show you this one here. Instead of this one here, I can access and print out the value also with this form here, with this pointer arithmetic, which means, let's get rid of this one. Oops, Control Z, Control Z. Let's go this one, and I use now pointer arithmetic here, which means I can print out this one here the same like here, because it's, let's see if this works. Perhaps it works not, and I talk crap. So first of all, I print out the first value. The first value, database ID, is just the variable name plus 0. And this plus 0, they most times skip here. That's why here first I made here the first one was just this difference operator and the variable name. That's why it worked without any plus, because they say the first element is plus 0, which means it's the first element. Then they skip this parenthesis here, and they skip here this 0 and this plus, and they just write here this difference operator, because the first element is just pointing to the first element. Here, let's read the array to decay constructor again. It constructs a pointer to the first element of an array, and exactly this one is it. The first element can be represented here like so, but you can also say I skip this one here. This one is also the first element. So this one is also the first element. So you have to keep in mind, these are not the pointer arithmetic presentation. This is just the normal one with, let's say, with omitting this 0, this plus, and this parenthesis. But on the second one, you can't avoid this. You have to use now the pointer arithmetic, because you want now point to the second element, which means you get here this data user ID, you say a plus here. I want not the first one, I want the second one, which is this one. And now you can write this, and when we do this one and print this out, you can see, okay, there is no space. Let's make here a space too, so that we can see it a little bit better. All right, this one is a space. This one is nice. And now you can see it prints out the first element with as a pointer presentation, and the second element also with a pointer presentation. And this is so the start. Yes, these are so the cases which you have to consider with pointer array to pointer decay. But this what I showed you here is not the complicated part. It is just that you have to understand this one. This is still the easy part. If you understand this one, then you have understand more or less what this array to pointer decay is, but not absolute in detail. But this is the thing which you have to understand. Let's say so. This one is, you have to know this kind of stuff in programming as a basic later, because you can see this one here. You will see many times here function with pointers, and most think then when they see something like that, okay, this function can take only pointers in, and that's not true here. You have to think that an array can pass in a function as well. So that's very important. And then some people will probably program it with this one here. Others, let's say some people will use this one here, other people will use this one here, and probably they are passing in pointers instead of arrays. And interesting is also here to mention, one people might use this one here, but is passing a pointer to this one here. We have not talked about this way, because this one is a pointer, right? I can pass here a pointer as well, the other direction. And yeah, that brings a little bit confusion, and that's why it's very important that you understand this, that an array can be treated as a pointer, and in programming they are using sometimes this version, sometimes this version, and you have to know it, and that's very important. And like I said, pointer arithmetic is a special topic again, because you see this +1 here is not the standard +1 we know with numbers, because here we will talk a little bit more about this one, and you should read a little pointer arithmetic if you want to go a little bit deeper into it. It means just it takes the address of this one here, and this +1 here says I will point to the next address, and in this case it's an array, because we know it's an array, and this one will be initialized right, because if you make here, for example, let me show you something. If I make here +5, right now you violate the rule here a little bit. Why you are violate the rule? The reason for that is this array which I pass here has only 2 slots, which means I have only 2 elements in it, and if I make +5, I'm not in the range of this array anymore. I going to a space, storage space, which belongs not to me, and I have normally nothing to do there, and you will cause there many problems. Let's see if I get here an error. No, I get an error. That's good. Sometimes you got not even an error there. We will talk about this later more, about pointer leaks and memory leaks and something like that. But this is a little bit more later. But in this video, I hope you understand the basic of array to pointer decay. We will go a little bit more deeper in this one, because I want to show you also how this works behind the scene with this storage, and with this how the pointer actually, what happens when you make this pointer arithmetic, what happens there, how the storage is used. Then if you +1, it goes to the next storage and still is okay, and so on. Yeah, I will show you exactly that, and here you can, I think that's interesting to know. All right, I think if you understand this one here, because this one is the absolute basic which you really try to understand, this one here, that an array can be presented as a pointer, and then if you use an array as a pointer, then you need to know about this presentation, which is pointer arithmetic. Let's correct this one here, and then we will talk also later a little bit why it is called decay and not implicit conversion. The reason for that is when we present an array as a pointer, they say we lose information, and what kind of information we lose. For example, here in this array form, I see exactly how many elements I have, right? I see there are 2 elements, and I see I can pass here an array with 2 elements. But I can pass here an array with 2 elements as well. The problem is here I don't see that this array is 2 elements long, or I don't see. Yeah, you see, we lose information, and that's why they call it here this decay, because of loss of information. Not really loss of information. It's, let's say, the visibility for the programmer is lost. We can't see directly what we are passing in. And about this one a little bit later when we dive really into this behind the scene. And I hope you understand now this one a little bit and try to go into it, because they will use this much, pointers will be used much, this one array, and of course don't forget we have here in function also something like references, and later we have there more. That's why it's very important to learn really this kind of basics. Yeah, I stop here, and in the next video I will go probably to the last talk about this one, this array to pointer decay, but there I will go really a little bit in the storage. We talk about then storage and about yeah, I will try to draw this one and talk about the types a little bit again, and that's it. All right, with that said, if you have any questions or any complaints, like all time, write it in the comments, and see you in the next. Good luck and bye.